Wolff Kishner reduction. This reduction is also employed for the conversion of aldehydes and ketones into hydrocarbons, and this reduction takes place in alkaline medium. So Wolff Kishner reduction is particularly useful for acid sensitive aldehydes and ketones, and the reaction involves treatment of the aldehyde or ketone with hydrazine in presence of strong bases like potassium hydroxide or sodium ethoxide. For example, when an aldehyde, say acetaldehyde, is treated with hydrazine NH2 in presence of KOH, the final product formed is ethane CH3CH3. Similarly, if you start with, say, acetone, when acetone is treated with hydrazine in presence of KOH, the product formed is CH3CH2CH3 propane. And when benzaldehyde undergoes Wolff Kishner reduction, the product formed is toluene. Now let us see the mechanism of the reaction. The mechanism involves two steps. The reaction, there are two steps. First step is formation of the corresponding hydrazone. There is a condensation product of the carbonyl compound with hydrazine. For example, if you start with a ketone, say R2CO, first step is condensation of the ketone with hydrazine to form the corresponding hydrazone. And the second step is decomposition of the hydrazone in presence of alkali with the evolution of nitrogen to form the corresponding hydrocarbon or alkane. The reaction takes place in alkaline medium, so the OH minus ion, it abstracts an H plus, so minus H2O. We get an intermediate. With negative charge on nitrogen. And this is a resonance hybrid of these two contributing structures. And next step is exchange of a proton with water. We get an intermediate having the structure. Again, there is a replaceable hydrogen atom present on the nitrogen. So the next step is OH minus ion abstracts the other hydrogen atom and we get the intermediate. Having negative charge on nitrogen. And this intermediate eliminates a molecule of nitrogen and the intermediate, resulting intermediate is R2 CH minus a carbanion, which exchanges a proton with water and we get the final product alkane. So this reaction, Wolff Kishner reduction, it converts a carbonyl compound into a hydrocarbon and the reagents employed are hydrazine in presence of alkali. And the first step is formation of hydrazone and the second step is decomposition of the hydrazone. For the different steps are attack of OH minus and replacement of a molecule of water, that is a proton is eliminated and we get an intermediate which is resonance stabilized. Next step is exchange of proton. Since the reaction takes place in alkaline medium, we can write this step like this. And again, we get an intermediate from which a molecule of nitrogen is eliminated. And next step is exchange of proton with water and we get the alkane as the final product.